Cool. Let's go ahead. So where were we? Main. Okay, so this is somehow basically taking the text. We were splitting the text in what? In input and output, right? So the output just being the next character. Yeah, but we had the problem. So we had the problem with the broken words, and I think that we maybe just need to flip the tasks. I think what we need to do is next token prediction. You know what I mean? And then token. So it's very not clear, right? So okay, so let's just ask tools. Let's just ask Ghostwriter again. So I want to build. Well, I'm coding an LLM for basically the next character prediction or next word prediction. Next character prediction. Chat like GPT. Next character prediction. Can you outline the steps to prepare the data? My current question, my current doubts, right? So my current doubts are basically around should I first tokenize and then split input and output for next token prediction? If so, how do I structure my vocabulary? Should I first split IO before tokenizing and do next character prediction? In this case, I don't know how that's compatible with the vocabulary. You know what I mean? Like the vocabulary is just words, right? That's the way that I thought about it. Give me a second. I think I need to tune down the volume a little bit because this might just be a little too loud. Let's see. That's probably better. So that's kind of like the struggle that I'm having. Like, because if we've got a vocabulary of words that then at the end of our process, the neural network says that's the next thing you should say. The vocabulary should be. That's the unit of work. Is it character? Is it a token that maybe represents a syllable? Is it like a word? You know what I mean? Bro, like, can you answer my questions? So let me just. Should I? So the first. Okay, so for next character prediction. For next word prediction, two sections handle input tokenization. So the first section tokenizes the input sequence by converting each character into input sequence corresponding assay value. Then it creates padded input sequences by adding zeros to the end. Each input is represented tuple padded input sequence target output tokenizing stored tokens. So both approaches tokenize the input sequences, but they differ in how to handle splitting the next token prediction. In the first case, the input and the output sequences are split by character, while the second case, the input and output sequences are split by word. If you want to do a next character prediction, you can follow the first approach where you tokenize the input sequence at the character level. In this case, you can structure vocabulary as a set of unique characters present in your input text. Yeah, but that's not the point, each character. So if you want to do a next word prediction, you can follow the second approach. In this case, we can construct the vocabulary as. Okay, so that's So does GPT do character, word, or something else? Prediction. It's next word prediction. It does word prediction. Sky level prediction, or even sub-word level prediction. It shows a prediction ground try depends on the specific. Let's do next word prediction. Okay, I think that's going to be easier. Okay, so let's do next word prediction. Okay, so let's do cool. So we do next word prediction. So we'll stick to this. So we have the text, and then we do generate the input output pairs. Okay, so in the code, generate input output pairs. Okay, so we've got this code. Let's start from here. Thanks. So help me to input prep for next character prediction. No, next word prediction. Next word prediction. Our starting text is like this. Give me code that text is text. Text is text. We'll ignore sentences or not. Text is text, and creates input output pairs. Input output pairs. Input output pairs. So the input part should consist of, I don't know, let's say of window size words. Window size words, and the output part should be a single word. Generate the pairs so that the window is basically iteratively moved by one word. Exactly. For example, if text is word 1, word 2, word 3, and window size is 2, then we start with the following pairs. Word 1, word 2, word 3, so that's what we want to do. So word 2, word 3, word 4. Exactly. So we basically create those pairs, and then we just tokenize each word. Okay, so let's do that. After that, we tokenize each word by, we'll just basically do, so we tokenize each word. So what do we tokenize each word with? We tokenize each word. We tokenize each word by we tokenize each word basically by an array of D model, of D model numerical values, which should be basically the encoded characters, and padded by 0 if need be. Let's see if that works. Okay, so we're gonna ignore little details, right? Like we're gonna ignore little details like the punctuation right now. I think that it's something we can just deal with later. But essentially what this does is just saying split. Okay, so it splits this into words. Let's just get rid of these. So split the text into words. Cool. Then generate training examples. Input output pairs. Let's see what this is doing, right? So input window size 3, window size 2. So print tokens. Let's just print tokens. So tokenize. No, print. Let's do that. So print training examples. Okay. So let's run this. Lorem ipsum dollar seed, $seed Ahmed. It looks good. It looks good. Okay. So it's an array of things, and then that's the next thing. Yeah. Okay. Cool. Print training examples. Not so sure if that's the format that we're gonna have to have, or that we will want to have, but that's fine. Then tokenize the input sequence. So let's see actually if can I just print 1, right? Lorem ipsum dollar. Yeah, that's the first thing. Cool. So then we say now tokenize the input sequence, tokenize the examples, training examples, tokenize the training examples. So training examples. So let's see if that works well. Okay, so we basically get these words, and then, yeah. Okay, so actually, what is not correctly done is the output should also be. So modify target output, padded input sequence. Okay, so I think this target output is the same basically. Padded inputs. Pair 1. Input sequence. Target output. Can you take the, so make sure it's of D model length and padded with zeros. So okay, so let's just do these tokenized examples. Cool. Okay, seems to be correct, but that kind of essentially means, yeah, whatever. So that's fine, because then what we want to do is we want to enrich those encodings with positional data, right? That's what we already did like many videos in the past. Okay, but that now makes sense. I think now that makes sense. Now let's construct a vocabulary. So construct. Can you give me a vocabulary. Now the question is whether I should be using the indices of these vocabularies or not. No, it doesn't matter. I don't think it matters for now. Can you give me a generic but reduced English vocabulary? An array. Generate one with like 1,000 words. Common words. What the fuck? It's interesting, yeah. No, that's not what I want. Come on. Use less common words. And don't sample. Just give me the array. Okay. Expand it to 1,000 words, please. Oh, come on. It doesn't. What? I meant expand the vocabulary. The vocabulary. Give me 1,000 unique English words, all in a Python array, please. Okay. No, but that you're sampling. You need words. That's not. So how can I import an English vocabulary to use in my LLM? Maybe I just need to import it from somewhere. I don't know. Okay, so there's some stuff. Download words. Oh, okay, interesting. Let's see if that works. Install the NLTK library. Let's see. So, Python, download words. Download words, and then okay, so can I just vocabulary, English vocabulary, good. Can I use NLTK a sentence out of the vocabulary? Sentence length. any given length. Yeah, but that's just like whatever, right? Using these, that's just a random choice. Random. I don't want to do that. Can you give me an English sentence, an English text made up of 5 sentences? Just like give me one. No, give me the actual. Don't give me code. Give me the string. No. I want a string. I want. It's the Ghostwriter seems to be too much like tuned to work with code, right? So, let me check one thing, guys. Just one thing. Okay, so I want you to give me a text in English that contains 5 sentences and give it to me as a string. Is it just that easy? That difficult? Oh, no, no, no. I don't want code. No. Don't want code, but I want you to generate the text for me. Don't make me go to ChatGPT. Don't make me go to ChatGPT, please. Please use common English words for the text. Come on, I'll go to ChatGPT. Sorry, guys. But because I don't have my history clean and I don't want you guys to see all my secrets, I'm just going to put it in a secondary screen, and I'm just going to do the same. Give me a text in English made up of 5 sentences. See what ChatGPT gives me. Yeah, I like that. Okay, so ChatGPT gave me these. ChatGPT gave me these. Cool. Can you give me an English vocabulary in the form of a Python array? I'm just curious. You guys don't see that, but like, it's actually doing it. Can you? So, but it gave me just like not so many. So, can you give me one with a size of 5,000 words? Will it actually do it? I think it's doing it. This is gonna try 5,000 entries. Okay, it's fine. I know. I'm just gonna assume that works with words. I don't know if it actually is doing this to stop generating. It's fine. So let's do that, and then let's see first of all if that works at all. So we've got a vocabulary. We've got a text. Then we're splitting the text into words, and we're doing this. What could go wrong? So it's updating the packages, Replit, awesome. Don't need to do anything. Installing all the stuff to get the English vocab, to get that English vocabulary. So okay, cool, yeah. Unzipping words. Okay, so it's actually, has it actually done anything here in the files? The words in here somewhere? Whatever. It works. Seems to work. The general breeze. The general breeze. Cool. So, English vocabulary, English words. So actually, how can we check? What can we check? Can we check all the words and text are in English vocabulary? It doesn't matter, right? Actually. Yeah, it's fine. Print. So that's, I mean, that's just a quick. Can I actually check that? So. It's not iterable. Okay. Corpus reader. That's not how it works. English vocabulary. So, oh, let's see. Goes right. I can fix it. What lower words? Yeah. Copy, of course. Because that's what we want. All like this, just a huge amount of work that goes into. It's not iterable. In words. Oh. But actually, first of all, this should go here. That's for sure. But then it's like line 29. It's just telling me words. So words. Okay, so first of all, can we just print that? Can we just print? Can we print English vocabulary? What is it gonna do? Oh, it's actually boom. Yeah, man. If it's if it's not, if these words are not there, then we're screwed. So that's all fine. I don't know how usable this dictionary will be, this vocabulary will be, but that's fine. Sorry, I'm gonna close that, otherwise I'm gonna die. Okay, so we've got a vocabulary, we've got a text, we've got a words. So let me stop. Let's just not kill this thing. It even takes a while to stop. And what I wanted to, what I want to do is okay, so we've got this organized. Now we can go back to what the original main was doing, which is now we've got this stuff tokenized. And now essentially we need to already jump to the positional encoding part, right? So we need to do positional encoding on these things. This is where it gets tricky, where it gets tricky, right? Because and I'm just thinking whether batching here is going to make sense or not. For that example, we'll just maybe keep it. Can we just keep like the batch size is just one at a time? You know what I mean? This is going to be a very small thing, so I'm just gonna let's just go back to it. Just let's say no batch size. We have the window size with the max. I don't remember what max len was. I think I'm gonna get rid of these, and we're gonna just do okay. We're just gonna do multi-headed stuff. This for sure. Multiple head attention. D model. Positional encoding. Maybe not. Maybe we just get rid of these. We get rid of all the complexities. Maybe we can just do one head. Like the multi-head stuff was just performance, right? So maybe we just use one head. See how bad this is from a performance perspective. We're just going to train something very small. Like, I feel I'm just coming back to almost like the very beginning, but that was good exercise. And now kind of like a step back, and let's just stick with this D model. That's the dimensionality of how we want to tokenize the different words. The window sizes for generating this stuff, and then let's just now do with positional encoding, and then the multi-head stuff, right? So main original, next word prediction example, convert the tokens, split positional encoding, to the input tensor, and all this kind of stuff here. And then we have loss function. Okay, so the original one just goes away. And then we've got the training steps, blah, blah, blah. So I think that's the one we should be now kind of be following a little bit closer. So we just have, okay, so now we just have training examples, and now we need to go from there. So examples and targets. Now that's maybe the next step, right? So I'm not so sure, but that's kind of, how do we do the position encoding? So that's the next step. Positional encoding, and we are gonna go to the attention file, because that's this one here, and we're gonna go to, and we're gonna open the main one. I mean, it's already open, it's here. So this is how the positional encoding is supposed to, it's in here, right? Is it here? Yeah, positional encoding is here, exactly. That's all we need now. Modify, but then the way, okay, so that's going to be the next step. I'm going to stop now. See you guys in the next video. I mean, let's just quickly run this. What do I get? The console. Do I get a console? Yeah, exactly. Okay. To date, and I get this. That's fine. So now we basically need to just encode this data with positional encoding. I'm not so sure if that's then something that's done locally, or it's done taking the whole context of the sentence. You know what I mean? See you next time.